Alright, we're just gonna wait for right, so I'm just waiting for the channel to come up. So Facebook on which one YouTube live. Alright, so this is probably gonna be the last live stream I'm gonna do for the day for this program, and I'm gonna do some more tomorrow. And I just want to knock off a couple of things for today. Just lunch and chilled out a bit, and then chilled out a bit too much. So before I get too much wine, I want to use a little bit of coding. So let's see where we ended up with. Alright, so we got laser. That's I think we've got all the base code correctly. And move it. So that we'll have 1, 2, 3, 4, 5. Let's see how that is on the field of view. Yeah. Yeah, that feels kind of nice. That end. Laser beam. So we'll have 4 fill. So we're using an alloy stock for this. I'm going to say that. And that's just thinking if I got sound. Let me just check that. Sorry. I'm getting too cold of these guys.
Mic test, hello. Mic test. Mic test, hello. All right, so apparently I was on mute for the past couple of minutes. Yep. Brilliant. Yeah, so what I've been doing basically is going to be possibly the last stream I'm going to be doing today, and I just want to knock off a couple of code before I call it a day, and yeah, before I get too much wine in me. So yep, so sorry about a technical glitch earlier on. I knew there was going to be something I forgot. Anyway, so we've got what I'm doing now is just basically duplicating the mesh that we have, the lasers. So we're gonna put it on all 4 corners, and we're gonna have to target the middle of the camera point of view. And that's what we're gonna do, and then see how far we get along. So we got 3, and then the material, what did I use on the first one? I used that one, so let's see how that goes. And we have this. It's looking a little bit more white than cyan though. Need to check that material instance. Alrighty, so let's see how that goes. No, not yet. Come on. So we're gonna have the transform offset. So we've got one at 25, 25. So we need one at negative 25 and negative 25, right? So the next one would be 25, negative 25. So 25 and negative 25. And the third one, gonna have 20, negative 25 and 25, right? And forgot to do the scale here. I need to remove that scale at some in a while, but for debugging, it's nice to check that out. Okay. It's kind of looking how I want it, but let's see how it plays. Oh, that actually feels good. That is looking super awesome. That's looking really good in a headset. Let's see. All right, so now we have the issue of rotating this towards here. So we're just gonna have to rotate the laser beam towards the center of the camera here. And to do that, we need we should need a range. Let's look at my notes. There you go. Yeah. Sorry. And my neighbor has started drilling again. Perfect timing. All right. Anyways, let's go back to C++. Okay, for the laser component, I can make it, I guess, as a part of the struct here, but it doesn't make sense. We want to scale it all at the same time anyways, so we'll just do it from here. Well, we're gonna have just one single range anyways for all 4. So we're gonna make a public property for that. So we have that, and that, and what do we do? So we create a float called range. Okay, let's just put a default value there. There. Then we have, what else do we need to do? All right, so now we can do some basic vector math. And there is a function in the Kismet or the blueprint libraries for doing a find lookout rotation. So we're just gonna reuse that, I guess. Yep, gonna reuse that. So let's put it here. Kismet. This is one of the common things I guess you'll be using. So Kismet math library. There you go. All right, I got that. Oops, it's the same material library. Come on, IntelliSense. So we've got that. All right, so just getting my bearings here. So we got a range, reset the range here. And once we've, let's actually put a pretty nice default there to 1000. Set a 0. All right, so, but we'll expose that to Blueprint with a uProperty macro, so that should be fine. You can edit it in Blueprint later on if we need to do a quick tweak. And for this one, I just need to be able to, all right, so I'm just gonna explain what my thinking is. And if I've learned how to open up the chat, which I haven't. Anyway, so, all right, so we've got all of those 4, right? And we want to have 1000. So roughly maybe around this distance around here would be my target. And I want the lasers to be pointing at the middle of the target here of the camera, because we want to target that that actor in a scene, right? So they should just be rotating here. So to get to be able to do that, I can use a node in Blueprint for that. So if you're used to blueprints, you're probably familiar with the node. Let's see, do I have blueprints here? You're probably familiar with this node. It's called find lookout rotation. So we're going to use the same thing, but I'm going to call it from C++. So I specify a start from there, and then I'll specify a target, which we're going to calculate doing some basic vector math, and put it somewhere here. So we're going to have to calculate this vector here. This will be a start location, and we'll figure out what this location is based on the range that we've just specified on the C++ end. Just going to clean that up 1 sec. All right, then go back here. All right, so we'll we're going to need a new function now to fire the laser. So it's going to be a public function, and I want to expose that in Blueprint. So got my code snippet there for the macro. So I've got U function. It's going to be Blueprint callable, and I just have like a category VR there. So, and this function, just do we need to return something? Guess not. So we're going to do void fire lasers, I guess. Fire lasers. And since we're going to fire all 4 for now, we'll see how it goes. You might want to fire them one at a time in sequence or something, but for now that should be fine. So we'll do fire lasers, and what I like to do is something like this. Gonna define that. So we've defined it here, gonna implement it on the C++ side of things. Put it here, fire all lasers. Right. Put that in there, fire lasers. Copy that, then there. So and let's do an where's the curly braces? 0, I guess. 9. Oh, what? Okay. Sorry, fiddling with my keyboard, trying to find the curly brace on the German keyboard. There you go. So it's all GR7. There you go. All right, so we're gonna fire all the lasers. First, we're gonna do calculate the target location, and then find the laser rotation. And after finding the laser rotation, do the, what else do we need to do? Yeah, we can scale. We'll do the scaling in a while. We'll do it one iteration at a time. So I could, normally I would go through all of the code right now, but for the purpose of this live stream, it's just gonna do it one iteration at a time, and also helps because I'm not quite used to speaking like this and thinking and then doing. Also might help me to kind of break it down a little bit for easier understanding for everyone out there, and also for me to keep testing and make it easier for me as well, in case since I'm thinking of what I have to say and then typing it in, see if I missed something really quickly. All right, so calculate the target location should be relatively easy. Some simple vector math. Target location. So easy. We're gonna do a, since we have an array of a struct, we've got 4 of them. We need to add them in a for loop. So we're gonna, oh, where did it go? Surround width. Where's my surround width? Yep, there you go. Surround width 4. Yep. And the length of, what did I call it? Laser beams. Length of laser beams. All right. So it's the maximum length of the laser beams. We iterate through all that, and we calculate the target location of a laser beam. We'll probably want to do another surround width here. Then if I'm a little bit paranoid with null pointers and such, so we're gonna do if laser beams if laser beams the laser mesh component. I only need to test for the component here. If laser beams laser mesh component is valid, low level. Let's do an is valid for this one, because we don't want to do a pretty hefty check in the middle of a game. Why? Oh, darn keyboard, I swear. Let's let test compile. Because I'm kind of running a bit blind with IntelliSense acting up on me. It's not a big deal, but well, it is a big deal, but it's just annoying. Yep, so I was pretty sure it wasn't available, so you need to do, I could do fast as well, but let's just do a no level. Should be okay for this game. If we need to improve performance, I might need to change that, but I don't think that's going to be a big deal for this game. So let's just do a test compile. That's fine. So all right, let's continue. So we've got target location. So we get the we'll need to get the current location. So which is what? Laser beams. Let's just copy paste this. Laser beams I. Then we get the seriously, why is IntelliSense not working with that one? Okay, laser mesh component. I'm pretty sure get location, get world location. I believe get world location is available in there. So get world location will get us a component's location in world space, and then we're going to use that world location and do something. Come on. Do a quick compile to see. Or we can just look at the API documentation. Oh, come on. Shouldn't take that long. the get component location. Let's just have a look. So problem when you have, it's kind of like losing the right click in Blueprint. I've done this 100 times, but sometimes I guess it shows like how much dependent we are on such things. I know roughly what it is. Get so view static mesh component. It's probably, yeah, makes sense that it would be, should be on the same component actually. Yep, okay. So we've got get relative transform, get location. Oh, interesting. There's get component location. So, sorry, I normally remember these things, but I guess that's how dependent you are. I am. The IntelliSense. So we've got, it's not really just type location, find the closest one. So we've got get component location and get actor location as well. And also sometimes Epic changes this. So just blame it on Epic. Alright, sorry. So we get the current location and then we're gonna get the component location again, convert that, oh seriously. Nine. Alright, so from the old world location, we're gonna get a, actually we're gonna get component rotation. So from the F rotator, we're gonna get the, the forward vector of the rotator, right? So if we get that, get vector, I believe, if I remember correctly, let's just, all right, so it's just vector. All right, so get component location, del vector, and oops, where's the plus? That plus. All right, so that's a forward vector. We multiply it with the range that we've set up. Yeah, and that should give us the target location. Pretty much. Yeah, so we get that multiplied by the range. Check why my IntelliSense is on the fritz. Oh. Was that the... No, can't be. Quaternion. Oh, it's a... Let's see what it has. forward vector. I could have also seen it from the API properties. I wonder if it's correct, so we'll find out if the laser goes around like into different areas. So you've got that, and that should be fine because the forward vector obviously is that one. It goes there, goes there. So now we get to find the laser rotation. So did we include that? Yep. So we're gonna have the Kismet library, and then we do from here find lookout rotation, I think. Yep, find lookout rotation. We'll get the starting vector, which is this one. And the target is this one. And that's it. So we have the rotator. Then we're going to set that rotation. To face the target location. Face the target location. There you go. So the static mesh component, we're gonna do whatever we need to do, if it ever allows me to. So we have the static mesh component set location or set component location. This is pretty good practice. It's funny, but all right. Set I guess that location. C could be on the mesh component. Actually, it would be on a higher than that one. I would say here. So we have set relative location. So what did you call it? I want to set the world location. Set world, don't tell me I need to transform. Set transform. Let's see what. Should be a setter here somewhere. Find a setter. I don't want that. K2, interesting. Why is that K2? We don't have one for. There you go. Set world location. So K2 is Kismet, which is blueprint. All right, so we have got that as parameters. And let's see what we can do. So the new location will be the target location that we just calculated here. And I'm gonna clean this up in a while. Gonna not worry about that. this one. And do that. Target location. That should be good to go. Do a test build. What else do we need to do? So yeah, I guess for now we just want to do the rotation and have them facing onto the correct location when we do a fire. Alright, so let's do that. And from here we're gonna do input. Let's see, where do we want to put that? Maybe here. So input keyboard space bar. Yep. Then we do a, where are we in pawn? Probably want that from laser. Fire all lasers. Ooh. Bye. Where did I put that thing? Oh. Fire lasers. And we have fire lasers, blueprint callable. Find it. If we can find the stuff. It's interesting it's not there. This hot reload not working for me. It's fine. What? Alright, so doesn't seem like the hot reload worked for some reason. Let's do a Steam project. Okay. All right, so let's see. There you go. That's really odd. Have that one, fire lasers, target. Okay, so once we press the space bar, we should be able to rotate this. And I guess it's better to test this not on the VR headset, but on the viewport. Alright, so if I press the space bar, that all of those 4 laser beams should hit the same place where that red laser beam is going to. Nope. And we're gonna see what happened. All part of the fun. So where did it go? Oh. And I set the look. Oh. Sorry. I seem to have set the, did I? Yeah, why did I do that? Yeah, of course. Okay. So we were looking at the target rotation. We should set the world rotation, not the location. So we shouldn't need to. Let's try it from here. Do a compile. Shouldn't need to build anymore. Alright, so now have it here. Let's play spacebar. Nothing happened. Okay, so we'll simulate. So instead of doing that from there, we're going to do that from somewhere else. Let's do it from here. That begin. Oh, where the hell did it go? How have I lost it again? Something really odd going on with the how to reload on C++ Blueprint in this version of the engine. I'm guessing. I had this much problem before with 4.17. I might need to test that. Could be a bug we need to report, but let's see. Could be just my setup, which could be most likely. Laser, and then fire lasers from here. And let's see. Breach. And then find the target. Oh, yep. All right. So I know what's happening. So the code works, but my math is stupid, so that's not working. I was doing a projection from, basically we didn't do much in here. The starting location should have been the center of the camera, not the not the starting point of the component, because then it will just basically do what we just saw. Basically put the target location, basically is just in front of the thing instead of coming from in the center of the camera. So we were just gonna do laser mesh. Ooh, laser beams eye. Actually, this component. Yeah, so we could use this. I still can't get used to that. Okay. Get location, I guess. So, get component location. Yep. Get component location. So that's how easy it is with sense. All right. So this get component location. Yeah. And then, but the actual rotation that we're gonna set is from the actual component. So that looks good. Should work now, I believe. I am about to sing. Probably lose subscribers for that. All right, let's see how we do. We'll do a simulate. Okay. I'm not doing what I wanted to do. So from the component location, dang, which shouldn't have mattered actually. Because the forward vector should still be the same, but then we're just doing an addition here. Normally a lot easier than this. Start. Alright, so the laser beams, if it's a valid mesh component, when we do a fire, because it happens on construction, that's fine. Okay, that's fine. Okay, now what I wanted, still. So rotating the laser mesh component to the target rotation. We're going to find the lookout rotation where we are at to the target location. And that seems fairly straightforward. Somehow it's not working that one. You get a component location. Ah, you're serious. Oh. Okay, I may have had too much wine then. Already. The hell? Okay, so I will explain it. Okay, so that should have been a rotation instead of a location. And target, darn it. Oh no, that's correct actually. We need the starting location, and then we need the rotation afterwards. But it could also be because when I fire the laser, we're just not seeing it. Okay. I'm just gonna do something naughty here. That's really interesting. Every time you build, somehow. Okay, with 418 it seems to be broken. Why? Hot reload seems to be broken. Let's see. That's gonna be troublesome for this. Just want to be able to quickly compile and test, right? So probably simulations aren't gonna work for this. Okay, you could see something happening, but quite not what I wanted. Okay, see that? That's fine. I can see what's happening here. Pressing the space bar. I think the rotations are correct. It's just that we don't have enough range for the x-axis. I was expecting it to be a little bit more. So if we do that, see, that comes up there. And that's probably what we want in the game. If we fire laser beams, if the player moves their head, do we actually want it to fire from where we initially targeted. I guess so. Yep. So we do that. Boom. And it's getting there. If I do this, it's always going to center towards that. It's, I think we just don't have enough range on the laser beam, so it looks wrong. Let's test that theory. The laser beams. Do 1000 on this one. Yeah. Yep, that looks right. So it's, we just didn't have enough range. So we probably don't want that to happen though, including that one. So we actually don't want that range to be used. Because we want to be able to do I think we can use because we want a different range for, just thinking if we actually want that. Yeah, we'll keep that. And we'll have we'll keep it. And we'll have the rotation. The only thing we need to change, I guess, is we want to be able to get when you fire the laser, we want to be able to get the current location, which we're already doing. Once we do a fire, we get the component location in world space. Oh, silly. That's probably why. So we start with the get component location, and we add it to we need a rotation here. So on location, rotation. So we need that, and we'll do this. And from there, the rotation, get the vector. So we get the component rotation, get the forward vector from that, and then we add a range, and then add it to the starting location. Oh. Sorry. It's like I'm not paying attention. Alright, so we have that there. Oh no, so this is a float. So remember, function, so that should have been right. But this should return an F rotator, and then the F rotator and do get rotation. Let's remember this one. Unless there's no get vector. I've sworn there was get vector. It's called vector, but I tried that earlier, it didn't seem to work. Maybe I was doing a component location earlier. Okay, so that I think, let's just restart this just to be sure. Hot reload doesn't seem to be working. And let's just put that back in there. 100. Let's do a test. Okay, so I kind of want it to be more, the rotation to be more acute than that. I think there's still something wrong. But if you look at the debug line, it seems to be right. Problem is we're projecting the target rotation somewhere beyond what the range of this is. So it will all look right once we do the actual scaling, actual scaling of this. So if we do, back to 500 for example. Yeah. So we'll do, yep, which makes sense. All right, so that looks right. We'll just do it to 100, back to 100 here. And actually we can just quickly test it. Let's just change the range to 100. And we just do that. And that should show up the way we want to, right? So, yep. Because we have 100 as a test. That's not going to be the actual scale, but all right. So now the lasers are pointing there. And let's remove that. Do a little bit of cleanup. Put that somewhere here. And there. Let's do a simulate. 9, not simulate, sorry. Play. So, all right, so we're looking at that. I'm gonna press the space bar and that's gonna be the laser beam. Okay, let's see if we look on here. So again, just want to get all the mechanics correct. Yep, that looks good, perfect. And we keep having a crash, I think. Yep. All right, so what else do we need to do? And then we'll put it all together tomorrow. Auto scaling to target, yeah, do that. Auto rotation is done. We've done this. All right, let's do the auto scaling. So to do this, we'll have to put back go to the laser. We'll do a 1000 range again. And we'll put this back to 1. So we're going to start making this look right. All right, so, oops, sorry, range should be 1000, this should be 1. I should have just had one transform offset. I know, the scale at least. Just triple checking. Okay, so it all looks good. So now they're barely visible. To simulate, they should just be small little rings, which we're going to scale in time. All right, so we've got all of those rings there, which are going to be the laser beams, and we're going to just project it out. Scale it up. Okay, so how do we do that? Back to C++. Alright, so we'd want to do that on the tick function. So the event tick, we want to be able to scale. So we'll need a property. Should we expose it? No. We'll put it as a private property. And we'll create a boolean is scaling. So it's always going to be false, but anyways. So, and on begin play, sorry, event tick, I'm gonna do, oh, where are we? Sorry, we're in the constructor here. Yep. All right, so we're gonna do if B is scaling, and if it's scaling, then we scale. So we get the, we'll do the same thing here. So we're just going to do that, and I'm going to go to all the laser beams, and if it's valid, but this time instead of doing all this, we're just going to do a simple scale. Scale mesh. So be faster, we get IntelliSense working. So with the laser beams, laser mesh component, there should be a set world scale 3D. It's like I'm world scale 3D, pretty sure, something along those lines. And then we have so where is IntelliSense? Anyways, what's actually, we don't want to set the world. Should be add world scale, add scale. There probably isn't any, at least I haven't used it. You probably have to get the current scale and then add a factor. So we got a set world scale. Just gonna double check if we've got add here. Makes it easier for us. We can do an add world transform. I guess that should work. Yep, so we do an add world transform, do an F transform, and we'll just use the scale. scale. Actually, I know that I'm just going to do an X scale, but that means we need to create a property that is one. Sorry. Create a vector called laser scale factor equals to let's make it really slow. Okay. That, and then we'll have, so the constructor should have location first, 0 vector, and then f rotator. So I'm just going by memory now. Bloody thing. 0 rotate, 0 rotator, and the scale factor that we just created. Laser scale factor. Yep. That should be it. So we'll just keep scaling. Actually, it doesn't stop scaling, but let's see. F transform is F vector, F rotator, and F vector. Then we make an F vector. Oh, what? Sorry. So we default is on the X, so we do 0.1F, 0.F, 0.F. Sorry. And that should be it. Just have to think. Seriously. Add world transform. Cannot convert from initializer list to F transform. We have a constructor for F transform. Why is F transform giving me such a pain today? Okay, so that was self-drilling F transform. All our constructors here. Could be because I need a quat. Alright, so some reason we've got a constructor here with the F rotator first, and then the vector, and then the location, and then the scale. Why? When everywhere else you have location, rotation, and scale. So let's not argue about that now. But yeah, so since I'm not depending on IntelliSense, I couldn't see what the next parameter should be, the different constructors. So we're just going to do 0 vector there, and that should work. And I couldn't trust all these red lines as well. the parsing doesn't seem to be working as well. I need to fix that before the next jam, or I mean the next stream. All right, so that was just it. So we're hitting some walls here, basic stuff. If you lose intelligence, that's pretty good. It's interesting to know how dependent I've got with it, which is probably not healthy. Anyways, I have that. All right, so we need a way to be able to so we're gonna rotate them, and after rotating them, we're gonna set face lasers to target location, and then we're gonna allow scaling of lasers. So B scaling. B scaling equals to true. We want to stop the scaling once it's reached a distance. So it is scaling on the thick component. Scale lasers, and after you've scaled all the lasers, check if we've reached the max distance based on range, right? So we'll do some math here. Set the, we will need the last location. Here we've calculated the target location, so we're gonna have to calculate where we are at this iteration here. So if we do set it, if we have the just get the length of the vector. Actually, we could just get the scale. So we'll get the scale of the X scale of the laser, of one of the laser beams. We could just sample one. And we want it to happen at the last one. So what we're gonna do is trying to find an elegant way of doing this. So we do laser beams.num if laser beams.num is greater than 0, and we do laser beams that, and laser beams.num -1 should get us the last index of the laser beam. Yep, if laser beams is valid low level, then what do we want to do? Then we'll get the laser beams, just get that. I think I should be able to access directly not actors. Component location. Roll scale. Okay, roll transform maybe. Transform. What? Get component scale. Okay, it's a function. So we get quad component scale. And I should be able to just access the Z. Oh, sorry, the X. That. Yep. Yeah. Level component scale dot X is what? Is greater than, it's greater than the range, laser range. I did call it laser range, right? No. I think I just called it range. Yep. If it's greater than the range. Alright, so let's gonna try to make that readable. Try to make that readable a little bit. Let's put that in a different line. This in a different line. Do that. And yep. Alright, so what's happening here? So we're just basically checking if we have enough number of lasers. If we do, we get the last laser and get that last laser. Is this wrong? And then we get that, we get the scale, we get the X. And if that X scale is greater than the range, then we would stop the scaling. And that gives us a one-shot laser beam, which we could easily build on top of. Or not. What? Oh. Laser beams. Oh. Dang. What is it? Did I use? It's a laser mesh component. Yep. Yep. Oh, all right. So maybe I should talk my way through that issue, but yeah. So it's basically because I'm using a struct here, and I'm getting the member of that arrays of that struct, but I wasn't doing the correct member. Oh. There is no is valid long num. That's not true. Got that there. Just typed it. Could I? Let's type that. That's strange. Yeah, must have had a typo there. Alright, so we've got that. Get component scale at X range and then B scaling false. That looks good. And if hot reload actually works, we should. No, hot reload doesn't seem to be working in 418. So it's basically like I'm creating code for plugin instead of directly to thing. It's either my setup or it's a bug, but it's a pretty major one. It's a bug. It's just gonna be really strange. Or it could be my code. So we've done a restart and we've done this. So we're gonna fire the lasers, and once we fire the lasers, we're gonna do, or it could be like it was really quick. And either way, we're not stopping the scaling. Oh, we're stopping the scaling, but we're not resetting the scale. But it could be really slow as well. So we'll have that. So range, where is my scale factor? So we'll do 1 there. Do test in VR. New. Go back here. Let's do a quick test again. And see what's going on. Alright, so what's happening there? Mustn't seem to be scaling. What did I miss? Fire lasers. E is scaling is equals to true. And at event tick, if we're scaling based on range, if laser beams that none greater than 0, which is true, and the last is valid, it should be true, and the last we get the components, get the X, it's greater than the range, should be false. Okay, what is our range? I thought I set that to 1000 because our alright, so let's try to debug. Let's remove that. So now once it scales, it will always scale. And it would be nice to be able to not have to restart the editor for this. Okay, so we do simulate. New scale factor is at X. Yeah. It's like event tick is not happening. Or this part isn't happening. So see it again. So scale is the last one, right? So we're just adding a delta. Add world transform. So that should be okay. Go directly to using component. Find, oops, set world transform. Actually not. We want add world transform, and it's a delta transform, so that looks okay. So we're using it right. So that right. Okay, now it's working. Come on. So we have rotation. Oh. Alright, so no, that's F transform. What? Alright, so we've got that right. Looks like. Maybe? And using component add world transform. So we have local component transform. So we've got delta transform. So this is actually what's happening on the code. Okay, changes it to a quad and then does it. Seems all good from that end. We'll have to look at the laser mesh component. It's valid low level. So it could be that we're not even hitting this one, right? Maybe it's time for logs. Laser beams, laser mesh component is valid low level, and then we scale the mesh. Laser scale. And that happens every tick. Okay. We're just gonna break the code. And put a range of course. Oh, there we go. It said hot reload complete. Maybe I was too impatient. Let's see. Either we have a crash or we have nothing. Oh, it's interesting. Should be at least something there, yeah. Okay, time for logs. Or in VR, it's better to have it every tick. Laser beams. V scaling is equal to true. Just can't believe it's not working. And we're not even setting this one, so it's all just this code that's somehow isn't working. Let's do it hard-fashioned way. Let's try this. Oh, are you kidding? Laser beams I. Right, laser mesh component. Okay, world scale. Scale. Come on. Get component scale. New. Yep, get component scale. That X. Plus laser scale factor. That X. Alright. X, Y, and O. What's happening? That's it. And that's it. That's fine. That's fine. That's fine. We have that. Yeah. And this. So we're going to do it a different way. See if there's something wrong with that. Bold transform. Laser scale factor. What is it called? Set world scale. Set world scale 3D. When did I do that? Set world scale. Oh. Set world scale 3D. So it would be interested why this one worked out. Let's go. See if hot reload works. Find out. It's taking a long time, huh? Doesn't take. Huh. Fine. So I need to convert that to a vector. So now it looks good. So it's the scaling that was the problem. So I have to do that. That looks good. Yep. I still would like to know why. I'll worry about that later. Something simple I missed there. Anyways, we've got the, so I'm doing it the old-fashioned way, kind of like brute force. So we're gonna set, basically I'm setting the world scale based on the current scale and then adding the scale factor, which should have been the same as the other one. Somehow it doesn't. anyways, so we've got that, and we're now gonna do the is scaling equals to false here, and we're just gonna do a scale, and then try that now and see what happened to the rotation there. Okay, so if hot reload actually worked, we'll find out. Yeah, there you go. So you could see it's moving really slow. Let's increase that a little bit. So let's change the range. Oh, you gotta be kidding. So reload doesn't seem to work properly. See, I've lost the variables. Alright, let's do a restart of the editor. It's really buggy. Time to convert it to voice. Problem is the downgrade. We don't want to do it. Can't do a downgrade, I think, in the assets. Oops. Is that still there? Alright, so have that, and we'll fire the laser beam. Very slow laser. Now we should be able to see the scale factor. Maybe we should increase it to 2. And then we fire the laser. Should be faster. That looks good. Oh, 10,000. That's why. Let's change the range. So it's becoming fun now. Although we should have been here earlier. Oh, that looks good. Let's have that. Let's see if the speed is actually correct. And fire lasers. Ah, like that. So we now get to maybe it's not gonna be smooth though. Let's see. There's a way to change that, but for now, is it stopping or not? No, I think it's splitting, isn't it? I'm not sure if the scaling is actually ending, but for now it should be fine. That actually looks good. Seems to be what I want. At the end, if we create a good material for that, that should be fine. Sorry, I kept hitting the microphone onto the headset. It's like, yep. So we have a laser beam, and we can stop the scale, and then we need to maybe have a timer to stop the laser beam afterwards. So we'll need to create a timer, maybe do a delay. Yep. And let's just write that down if I forget. Here, timer. Laser scale. So laser scale, right? So that's a whole series of code I want to do now. So this is done. That's done. That's done. To do some more. So expose the scale. We haven't done that. Okay. We actually didn't do it this way, but do that. Auto rotation on. And we could do a little bit of, should we do the materials today? What time is it? 6:30. Okay, let's just do a quick material then while I'm here. So let's create a folder for the materials. Okay, so material library. And we do some of the redirectors there to be sure. Then we'll create a new material. And we'll do a target material. Oops. Let's fix up the redirectors. Okay. All right, so for the target material, do we want it translucent? Do we want to control the opacity for this? Possibly. Okay, so first we'd want the emissive color. So we'll do a emissive color there. We'll convert that to parameter actually. So color. Let's put a default like that. Oh, I should stop. That. Can I put that in? Oh, there you go. That looks better. We'll set an opacity here. We'll default it to 1. Let's look at how that goes with the plane. Your cube. Okay, that looks okay. So now we're gonna want to, alright, so I don't want to do a destructible for this game. I just want to do a simple material where we're gonna explode the vertices. So we're gonna do world position offset, get a vertex normal, and then we'll multiply it with a factor of, and then plug it into the world position offset. So that should work. So vertex normal. Hello, vertex normal. We'll do a multiply. Multiply. Yep. To a parameter, I guess. Yep. We'll do, oh no, maybe 1. We might need a good mesh for this. So just to test the world position offset. Yep, so you could kind of see it from here. The cube is exploding. We'll set this up to, let's try to do it to 100. Does it actually show in the material, or should be in the instance? Okay, so you can see that that's exploding. So we'll do it at maybe 0 to begin with. Oops, 1. Here. So we don't explode it by default. And we will convert this to a parameter to explode, yes. Then explode. And what do we want here? It's self-explanatory. So keep it as it is. So we've got that. And yeah, let's make an interesting mesh. Not just that basic one. We'll create a material instance out of this. And then we'll call it target material, and we'll follow the LR naming guidelines. Dang. Okay, so every time I rename, I just do a fix up redirectors, so my directories are clean. All right, so from here, it's better if we have a mesh. Just to do a test. Okay, it's been a while. Blender, let's see if I remember stuff. I'm not an artist, but should be create something simple. Yeah, let's just use an icosphere. It has a lot of vertices, so we can see how to explode it. Right, and let's generate some UVs in there. And let's save this to, where did we save it? We save it to Steam, Stream Projects, OpenGen. Alright, so this is the blend file. I'd want to, alright, so from here, I'd create a new directory prior to the content directory where I want to store the raw files. Alright, so we're gonna use that one and name it something. What do we name this? Icosphere. That blend. Save as Blender file, and that should be it. And yeah, we're gonna export it to an FBX file, which Unreal understands. I should have a preset here. No? Alright, so we just have to set the world settings to correct. That should be 1000, but let's try. So it's X forward, Z up for Unreal, and that should be it. And let's import that in under placeables, I guess. Add a new folder. Yes, so meshes. Then we import it. Here, icosphere. I'm hoping I did all the correct. We're not gonna import material or texture. Just gonna auto-generate collision. That's fine. That's fine. That looks good. And if we now, let's just open this and save it. Let's start. Now we can use this thing and we can have a little bit of fun with the explosion. So we do 25. So we have 100. See, that will be our explosion effect. It's kind of very neat explosion effect. Like a simple explosion effect. 2, 3, 4, 5, 6. So I guess it's kind of cool. Kind of like an art direction instead of using a destructible, which we could still do, but I think this would be good for something arcadey, simple arcadey style art direction, which we would probably be doing. So there, and by default it looks like this. Really boring. We'll probably add a texture here just to make it a little bit more interesting, but for now that's gonna be our target. Alright, so I guess we've done quite a bit in a couple of hours that I have left while drinking wine, so that's quite an achievement. Alright, so we got all the scaling, property for the laser range, make timer delay, which we can do tomorrow when I have my wits about me. Create an actor. I just want to take off some of the really quick ones. Expose the scale. We probably want to expose the scale and the material. unless we haven't done that yet. So we go back to the A target. So A target. Yeah, we have the material, so we don't have the scale. I don't think we'll need to do the location for this, or rotation offset. We're going to be controlling that from Blueprint, but it's just the initial settings that we want to change. So yeah, so we're going to just quickly add a property here for the scale. So we can take that out. Oops, sorry. We can take that thing off. So we're gonna scale as a vector. So it's we actually need two of them. Let's start with outer shell. Then we're gonna, right, I should be talking a lot more. So outer shell, then inner shell, right? Initial scale. So default should be 0. That's fine. So we're gonna then at begin play. What do? Create the actor's inner shell. If it's valid low level. Actually, we don't want this. Sorry, I just thought about it. We actually don't want that. That would be like really bad. We want an F vector with a scale of 1, 1. Do we have a construct? Oh, now my thing works. My IntelliSense works. Yeah. What constructors do we have? Okay, I was just thinking, I normally just type all 3, but maybe there's one that we just put in. Maybe, probably not. So we just do all 3. Just being lazy. Make that a little bit readable for me. Alright, so, and that should give us a default of 1 for that. Which kind of makes sense. Yeah. And then now on the target, we're gonna do the scale. So we've got inner shell and outer shell. So I hate this duplication of code here. We would probably refactor this to a function, but not now. So we're gonna do a scale. Oops. Doesn't need to check that. And possibly we need now to do a little bit more comment because it's getting a little bit unwieldy. So set up static mesh component and set the material of the component and then apply scale. So we then need to do the outer shell component. Oops, sorry. The shell component. We're pretty sure that at this stage it's going to be there, so I'm not going to do any validity checks for that. Set scale. I keep forgetting that. I just used that a while ago. World scale. Set world scale. So we just have cheat a little bit. Set world scale. 3D. And we have that there. World scale 3D, and we need to have an F vector, which we already have, which is the scale that we just created, outer shell scale. outer shell scale. That's it. And we're gonna do the same thing here. Need to refactor this. And apply the scale. Come on, it should build. And there you go, so we should have that built, and we can now define the scales. Of this thing. And I should have scales in there, yep. So we have the outer shell to 2, which will have a really big cube, and then inside a cone. If we do play, yeah, so the cube has become bigger. We might want to do rotations as well, because I kind of want to be able to rotate things. So that looks okay, because right now it's looking a bit bland because of it looks like a plane from this angle, but it's not. I really like that gaze. Right, and we fire a laser. Cool. Alright, so a lot of the foundation stuff is there. It's just putting things together tomorrow. And yeah, I guess that's all the basic stuff we need to have. And then we can have more fun tomorrow with a little bit of gameplay. Just remove that thing in there. Alright, so we've gone through a lot of sample debugging and checking. And yeah, a little bit of wrestling with IntelliSense. So, but that was good that it actually broke down like that. So kind of shows you what you can do if in case that happens. Either fix it, or an alternative method is just to look at the API. It's probably a good exercise anyways to just kind of get back to basics or back to yeah, the core of the programming. So, but it does make things a lot faster if that's there, because you can just flip through all the available ones, and yeah, because it's almost impossible to remember everything. Like, I should be able to remember a lot of these things by now, but apparently I was still relying quite heavily on the IntelliSense. So yeah, because a lot of these, of course, changes whether it's an actor or it's a component, and yeah, so there's a little bit of a consistency issue with some of the function names in Unreal, my opinion. So especially on that transform, where it was a bit weird that you have I think that was a rotation first instead of the location. So, and all these weird things, so it does help a little bit if you got IntelliSense working properly on your setup. But we managed, we survived, and this is a game jam, so it should be fine. Alright, just gonna do a build, and then just gonna commit this now to GitHub. Where is my source tree? Yep. So stage all of it, and then laser polish, laser functions, and a bit of polish. So we just push that immediately to master. And see how that goes. Oh, why is my name? What is that? Did I name my Blender file with an @ symbol at the end? Strange. Alright. There you go. So that's it for now. And we've done quite a couple of commits. So I guess that's a good starting point and a good ending point for this session. Alright, so I'll see you tomorrow, guys and gals, and see how we go and see if we can actually finish this. There's not a lot left. Well, there's a lot more left. Basically art and putting it all together and making it a little bit more fun. So let's see. It's kind of like the game jam thing, and see how much gameplay we could add into it. Alright, see you folks. Bye.